For decades, black holes have been known as destroyers, cosmic monsters that devour light, matter, and everything that dares to drift too close. But now, NASA's James Webb Space Telescope has found something that defies everything we thought we knew. Hidden deep within the distant universe, Webb has captured a supermassive black hole, not stationary, not resting in the heart of a galaxy, but moving at a speed that seems almost impossible. This runaway black hole is racing through space at nearly 4 million miles per hour, tearing away from its home galaxy. And behind it, stretching for more than 200,000 light-years, lies something no one expected, a glowing trail of newborn stars. Astronomers are calling it cyclone, the black hole that creates instead of destroys. Normally, black holes consume the gas and dust around them, ending the potential for star formation. Yet this one appears to be doing the opposite, compressing gas clouds as it plows through intergalactic space, causing them to cool and collapse into brilliant, newly formed stars. It's as if this cosmic giant is leaving a river of life in its wake, a celestial paradox rewriting the rules of astrophysics. Scientific confirmation. This astonishing phenomenon was analyzed by a research team led by Professor Peter van Dokkum, whose findings were published in the Astrophysical Journal Letters. NASA later confirmed the discovery using Webb's near-infrared instruments, which revealed both the black hole's rapid motion and the long luminous trail that follows it. The implications are staggering. For the first time, we're seeing evidence that black holes may not only destroy, they might create. This changes how we understand galaxy evolution, suggesting that black holes could be sculptors of the cosmos, not merely its destroyers. A galactic collision like no other. ARP 220. But Webb's surprises didn't stop there. The telescope also turned its eye toward ARP 220, a galactic merger so luminous and chaotic that it radiates more light than a trillion suns. Located roughly 250 million light-years away in the constellation Serpens, ARP 220 was born from the collision of two spiral galaxies nearly 700 million years ago. The result? A compact, blazing region of creation and chaos. Webb's high-resolution images show a dense, 5,000 light-year wide core containing more than 200 massive star clusters, surrounded by gas equal to the mass of our entire Milky Way. Within that glowing chaos, Webb detected two galactic nuclei, the surviving hearts of the original galaxies, still orbiting each other, separated by a mere 1,200 light-years. Around them, vast rings of fire, zones of intense star formation that blaze in the infrared spectrum. Faint filaments and tidal tails spiral outward, marking the cosmic dance that continues long after the galaxies first collided. It's a portrait of creation through destruction, galaxies merging, stars igniting, and cosmic dust forming the seeds of new worlds. Galaxies older than time itself, and just when scientists thought Webb had reached its limit, it revealed something even more shocking. Light from galaxies so ancient, and so massive, that their very existence seems to break the known laws of physics. Some of these galaxies appear to have formed only 300 to 500 million years after the Big Bang, yet they are enormous, structured, and mature, some even 10 times the size of the Milky Way. How could galaxies this massive exist so soon after the universe began? Using Webb spectroscopic instruments, astronomers measured the redshift of these galaxies, confirming that their light has traveled more than 13.5 billion years to reach us. These galaxies contain almost no heavy elements, meaning they formed during the universe's earliest, most pristine age, perhaps only a few 100 million years after time itself began. Do we need a new theory of the universe? For decades, cosmologists believed galaxy formation was a slow process that unfolded over billions of years. But Webb's data tells a different story, one of rapid creation, accelerated growth, and colossal galaxies forming almost instantly after the Big Bang. Dr. Michio Kaku and other physicists have suggested that these findings could force a complete rethinking of our cosmic timeline. If galaxies this massive existed so early, then the standard model of cosmic inflation, the very framework of the Big Bang, might be incomplete, or even fundamentally flawed. Perhaps the universe didn't begin with a single explosive moment, but through cycles, eternal expansions and contractions, or interactions with hidden dimensions beyond what we can see. Protoclusters and cosmic highways in the far reaches of space, where light has traveled for over 13 billion years, the James Webb Space Telescope has detected something extraordinary: protoclusters. These are not yet the massive galaxy clusters we see in the modern universe, but the seeds of them, vast collections of young galaxies forming only 650 million years after the Big Bang. Each of these protoclusters represents a snapshot of cosmic construction, a glimpse into how the large-scale architecture of the universe began to take shape. In Webb's deep field images, these early galaxies are not scattered randomly. They appear to be drawn together by invisible threads, the gravitational highways of dark matter. Astronomers describe them as cosmic rivers, immense channels through which galaxies drift and merge, pulled by gravity into denser regions, like droplets converging into a single, massive ocean. Over billions of years, these flows give birth to the enormous galaxy clusters that dominate the universe today, colossal cities of stars bound together by gravity and dark matter. What makes Webb's discovery so remarkable is how soon these structures appear. According to previous models, it should have taken billions of years for such massive systems to assemble. Yet Webb shows they were already forming when the universe was less than 5% of its current age. That means the cosmic web, the vast network of filaments that connect every galaxy, every cluster, every star, was already in motion almost from the very beginning. Scientists now believe that dark matter acted as the silent framework for this process, an invisible skeleton upon which the luminous matter of the universe could gather. Webb's infrared vision is giving astronomers their first true look at this hidden architecture, allowing them to watch the universe build itself piece by piece. Rethinking the Big Bang, these findings are forcing scientists to ask profound new questions. If the early universe was this organized, this structured, and this active so quickly, then maybe our understanding of the beginning itself is incomplete. For over a century, the Big Bang theory has served as the cornerstone of cosmology, describing how space, time, and matter expanded from an incredibly hot and dense origin point about 13.8 billion years ago. But Webb's discoveries are whispering a different story, one where creation may not have been a single event, but a repeating process. Some physicists now propose that the universe may cycle through endless phases of expansion and collapse, a cosmic heartbeat echoing across eternity. Others wonder if our universe is only one bubble in a vast multiverse, where countless other realities expand alongside our own. Whatever the answer, Webb has shown that the early cosmos was far more complex than we ever imagined. Each new image reveals galaxies already mature, already teeming with stars, and already interacting, as if the universe skipped a few steps in its own infancy. Perhaps the laws of physics we rely on today only describe a small part of a much grander cosmic symphony, one that began long before the Big Bang and will continue long after our universe fades into darkness. What comes next? The James Webb Space Telescope is still at the beginning of its mission, yet it has already redefined what we thought possible. In just a few short years, it has shown us runaway black holes leaving trails of newborn stars, galactic collisions brighter than 1 trillion suns, and galaxies that shouldn't even exist according to the rules of physics. And this is only the beginning. Webb's next observations will push even deeper, searching for the first light that ever existed, mapping the atmospheres of distant exoplanets, and perhaps detecting the faint fingerprints of life beyond Earth. Each discovery brings us closer to understanding dark matter and dark energy, the mysterious forces that make up 95% of the universe, yet remain invisible and unexplained. The telescope's infrared eyes allow humanity to see what was once thought unseeable, through cosmic dust, across time itself, into the first sparks of creation. Every pixel it captures is a message from the past, a whisper from when stars were born and the universe was young. The journey is just beginning. Webb is more than a telescope. It's a time machine, a cosmic archaeologist uncovering the buried history of existence. It stands as proof that curiosity, ingenuity, and the human spirit can pierce even the deepest darkness of the cosmos. Each discovery doesn't just answer questions, it creates new ones. Where did the first light come from? What forces shaped the universe before time began? And most haunting of all, are we truly alone in this vast expanse, or are there others looking back, through their own skies, wondering the same? Perhaps the next revelation from Webb won't just change our understanding of the universe. It will redefine our place within it. The stars have been speaking for billions of years. Now, for the first time, we have the tools to listen. And the universe, vast, mysterious, and alive, is only beginning to reveal its secrets.